And welcome on in, everybody. Good evening, good afternoon, good morning. Come on into the Dragon's Den. My name's Digital Dragon, aka Luke. I'm a 3D printing variety streamer here on Twitch. Let's see. Welcome on in, Modlight, Evil Diesel, Da Vinci. Evil Diesel's making excuses already. Not my fault. Not my fault. Did some more MacGyvering on your printer today and got a couple more prints. Awesome, Da Vinci. That's always good. Heat helps, and so does acetone soap. Yep. Well, it depends because acetone soap doesn't go as easily with PLA, and that was always running PLA. Yeah, cool. Hey, Chanel, welcome on in. Welcome on in. Glad to have everybody here. I'm glad to be here. I'm doing pretty well. The right eye is healing up really well according to the doctor, and the left eye is doing pretty good from the surgery. So everything's going well. I'll go back in 2 weeks and see how everything's progressing healing wise. But both surgeries went well. I'm seeing well. So that's great. That's great. The vision will continue to clear over time as the swelling goes down a little bit more. Hey, Subsector, welcome on in. I mean, I'll say the headaches, but when I mean headache, I mean it's just a low-grade kind of circular throbbing around the eye sockets, and that's just hey, go put in some clear eyes or other type of liquid tears, and maybe close your eyes and give them a break for a short bit. Stop staring at a screen. But yeah. Yeah, like I said, it just depends on the material. If you're doing ABS, then yeah, the acetone is going to help eat the ABS away. If you're doing PLA or PETG, it's not going to have the same effect. So, but yeah. I got me some coffee, and today we're going to continue on the K3 build, the printer so far. I have it sitting down here on the ground. I'll go ahead and bring it back up here, and we'll show off kind of where we were at the end of the last stream. Whoops. We had gotten our frame built, made sure everything was squared, and then from that we started adding our linear rails. There's all four edges have a linear rail, and then we've got our X gantry and our Y gantry. And today we're going to be adding the 4 motor mounts for the 2X, 2Y motors that'll be running the show here. And then if we can get into it, depending on how late we go and how I'm feeling, we'll start adding the gantry mount plate that will tie the 2 gantries together. And you'll start to see a little bit more of how these 2 gantries work together to get the linear motion. Were you trying to do a shout out there, Modlight? If so, it would be a bang SO, then Subsector 3D. There we go. ESR linear rails from Xiotech, good. They've got pretty good linear rails. I know Evil Diesel's used a lot of rails from there. Yeah, no worries, Modlight. I know you've been off for a little bit because you had some technical issues with a laptop. So no big deal there. The linear rails that you get from Xiotech are pretty good. Of course, I like the Honey Badger rails from Fabrico. LDO rails you can get just from about anybody. The KB3D rails and the West 3D Berserkers, they're all really good. And of course, you can never beat. Well, you can, but I mean, high wind rails for the win. But they're expensive. And if you're doing a printer that's kind of small like this, you may not see any real advantage out of it. But I'm going to go ahead and set this back down on the floor. because we're going to be building our 4 motors, and then we'll bring that back up here to actually mount them. I don't know if you can shout me out in my own stream. I don't think you can. Yeah, that's true. It might not work if you're on your phone. So I've kind of tried to lay some stuff out around here. So I've got the bearings, the idlers, the pulleys. We've got our 4 long boy motors over here. And then I've got some printed parts that we'll use that are kind of right off camera. And I'm going to show you one of the other things that just came in recently. If you were on Chris's stream yesterday, you would have known that I had received this. I got my Revo Roto in. I haven't 100% decided what this is going into, other than it's going to be one of my smaller printers. So it's either going to go on a the Micron or my V01 when I rebuild it and upgrade it to a 02, which is what I'm thinking I'm going to put it on. But this is our E3D Revo Roto. Okay, so it's a NEMA 14 pancake motor. The black part here is plastic, but this is the planetary gearbox that goes into the metal housing. And the metal housing will have the 2 drive gears that are tensioned and actuated with the lever. Okay. I did get the sensor version, so there will be a sensor package that sits on this that will add a filament runout sensor. It'll also have a thermistor that'll get mounted into the metal housing. And the fan that goes on will be 3 wires, so it'll have a tachometer. So it'll actually be able to read the temperature near the heat sink or the Revo nozzle. And sense the fan speed so it can tell and preemptively shut down if the fan is going, if there's an obstruction in the fan, or if we're getting heat creep. So this is going to be pretty neat. And to give you a size comparison, right, Revo Roto, full setup with motor, and a pretty standard NEMA 17. It's a little bit longer because of the long boy, but to give you an idea of what this size package is, right? So, I mean, this thing is really, really small. I'm really excited to see how it goes. And of course, putting it in like a V0, it's going to work well. It is really small. And the interesting thing is this housing, this metal housing here, the aluminum housing, to include this heat sink fins here, this is all one piece. And this is all printed metal. This is 3D printed housing. You can kind of tell at the top here where you get some of the support marks at. But this is a 3D printed metal housing that is then baked to anneal it. So this is going to be a pretty cool little thing that we'll get into on stream. And I did drop a tag off of that. Let me see if I can find it because I might need that at some point. Oh, there it is. Oh yeah, that would be pretty good. But it says kind of very critical. Max of 0.6 amps peak and 0.425 RMS. So you want to make sure that before you connect this up and turn your printer on that it's set to nothing more than 4.25. Otherwise, that would be bad. And yes, I can mod light. Let me just put this back in there and set this down in here. Put that aside. So your prints. Where are we at? So here's the blue. Either way, it would work with black or the standard stainless. Yeah, that one is not going to be enough. This is my other orange, right? Yeah. Yeah, so here's your dark blue and the orange ABS. Okay, so that'll be your colors right there. Okay. I've got all of the PLA parts printed. I just need to print the 2 ABS parts out, and I'm really close to being ready to do that. I've just been running the PC parts for the K3 build, and because of that, I've needed to run those. The PC parts run at 280 and 110, so I didn't want to have 3 printers running, 260 and above and 110 beds at the same time, because I'll probably trip the circuit breaker. So I've got just 1 or 2 more, so this will get printed and it'll be ready to ship this weekend. Okay. Yeah, the black 2020 should be fine. I mean, my 2020 is black and orange on a black frame. So without further ado, we are going to get started here in the motors. Let me come over here and, hey. So this is kind of what we're going to look like here. And there's kind of 2 different variants. One is using standard shaft motors where you'd have a coupler. And then the other variant, I'm going to scroll down here a little bit, is using these custom length LDO motors. And those, of course, are the ones that we have here. So these are what we refer to as long boys, so that we can put in everything that we need here. So yeah, so we're going to start off with just mounting all 4 of our motors to the motor brackets. Now, I did print motor brackets. So I did print motor brackets, and once again, these are printed in polycarbonate ABS. However, Hector at Fabrico sent me their CNC aluminum 2-tone brackets. So these are about 10 mil aluminum, and we're going to use these. Because the nice thing is these will kind of provide a heat sink for these. So if I run them in 24 volts, great. If I decide to run them separately at 48 volts, even better, because these will help heat sink them down to the frame. And I won't have any issues with the motors kind of slowing down or anything because of the heat. So we'll do that. And the other thing is people have had issues with the printed parts actually sagging over time, especially if they're printing hot and fast. You know, once again, that was one of the reasons I went with the PC ABS in the last couple of builds, is to deal with the high temp. I thought Walmart's been having self-checkout. That's when everybody walks in, just grabs whatever they want and walks out without paying, right? Sorry, maybe too early. So I need some M3 by 10s for the custom link, or M3 by 16s for the standard link. So because I'm using the custom link LDO motors, we're going to be using M3 by 10s to mount them. So my M3 by 10s, these are 8s. M3 by 10 socket head screws. Sorry, couldn't help myself, but yeah. Yeah, and I can imagine that, because I've been sitting here watching the news stories on some of these stores that are just getting pillaged left and right. And I can't believe that there's nobody that's willing to prosecute them. It just drives me insane. Because all it does is drive up the prices for everybody else that does actually play by the rules. Yeah. Yeah. Okay. So we've got a motor and we've got our mounts. We need to make sure, so on this side, our big holes have the counter bores to them. So this will be where it mounts. So it's going to sit like this, which means these are the 4 holes that will go onto the motor. And you can't necessarily tell it in this picture, but in this picture, there's our flat, and our motor wires come out towards the corner of the triangle. So we need to mount this so that where our motor wires are at is coming out by our triangle. So it's going to mount down on there like this. And because we're going through metal into metal, we're going to go ahead and put some Loctite on these to make sure that they stay put. And I did get in it had decent ratings on Amazon, but this is a Vanpo. This is a digital torque screwdriver. I just got in today and I haven't had a chance to look through it, but you'll be able to set your torque values in 4 different measurements. So inch pounds, Newton meters, kilograms, something or other. There's just 4 different measures that you can do. And we'll break this out and use this later. I just didn't have a chance to read through it to figure out how to use it appropriately just yet. But we will be using that to go ahead and tighten down all the bolts on our rails to make sure that they're tightened down to the 1 Newton meter and so forth. So we will break this out and I will go through and retighten everything to make sure it's properly torqued down, so that when we start ramping up the speeds on this, everything stays together. Once again, we're going to use M3 by 10 screws. Hey, Shenanigans, how are you? Do you have a Vanpo or the Wera, or which version do you have of that digital torque screwdriver. Doing good, Shenanigans. How are you doing? I think I saw you on stream earlier today. I haven't been on stream. Like, I haven't even watched any of Joel's stream yet today just because I had to get up and go to the doctor's this morning for my follow-up. Then we ate breakfast and went to the post office to mail something out. And then I came home and I've just kind of been in and out all day long again. Still trying to get over the anesthesia meds. Oh, it looks like we're getting ready to have an ad break start, so and I guess because I know we're going to build these and then put them in place, and I'm not going to be able to get to these screws real easy. So let me figure out where we're at. We're on page 31. I'm going to jump back up here to the torque settings. So M3 going through metal into metal is a 1 Newton meter. Should we try and see if we can't get the Vampo set up real fast and see if we can't get these things squared away right? Vamping is bad for you? Yeah. He just gets stuff. Yeah. Well, he's doing a charity stream for the Children's Hospital. So try and jump on there and give. I'm assuming the first thing I need to do is use the supplied screwdriver. Put our batteries in. Well, that was awesome. Give me a second as the spring just popped out on that one. Where did it go? There it is. That was weird. Thanks for the lurk, Ramon. Okay, and I'm not sure if which bits do they provide in this. Two, a 3, and we're using what, 2.5. I'm gonna have to see about using my iFixit bits. Yeah. And of course, these won't fit because they're too small. Do we have an adapter? Yes, we do. Okay. Yeah, you need one of these? Yeah, no kidding. Like I said, I got it just because this is the first printer I've been building where it actually gives torque values and tells you what you need to do. They default is Newton meter, so that's good. That's the torque value. Okay, so C to turn it on. It says we're in inch pounds, so we're going to do U to change it to Newton meters. Down arrow to get it where we need it to go, which is at 1. Okay. Long press to lock. And we should be good with that. Okay, so it doesn't take much to actually get these in and to torque spec. So that's good to know. So we got one motor plate on. We'll go ahead and get all 4 motor plates on, and then we will go from there. Oh, that's not good. Um, I know it's pretty expensive, but I really like the OmniFixo. Where you can, depending on what kind of circuit board you're doing, You may also be able to print a circuit board, like a PCB vise, depending on what size you need. Okay, so all these are just tightened and snugged down. We're going to so I get an indicator, and I'm not sure if you'll be able to see it. But as I turn this, so I'll get the two green lights and it'll go red with the double lights. And when it goes red with the double lights, that tells me I've reached my torque setting. So red with a steady tone, that means I've reached my torque setting. So once again, the wires are going towards the point on the triangle. Hey, Timur, welcome on in. Yeah, I was looking for a regular, torque screwdriver, with just the click, and I couldn't find any. And the Weras I were finding were like $70, but I would have had to wound up getting two of them because one of them did the lower torque range, like 0.2 to like 0.2 to like 0.1. And when we're dealing with the M5s, we have to go all the way up to a point or a 3 Newton meter, as shown here on the chart. And I would have wound up having to get like two different Weras, or there was a Wera that had that did cover the range, but it was two different torque screwdrivers and a bunch of bits, and it was like $180. And I was like, I can't spend that much for torque screwdrivers for doing 3D printers. Like if I needed it for the plane, a $90,000 plane, not a problem. Not a problem. But needing it for 3D printers, I'm not sure if I'll be able to get that one past Mrs. Dragon. Hand vise? Okay. Okay, so let me go ahead and work these down. Like everything else, just keep it constant. You don't want to be jerky and fast in your movement when you're doing torque stuff. Just keep it constant. And you'll get a nice good torque value on these. And I seriously think what we might do, since it's going to be the same setting because we're M3 through metal into metal, which will be that same 1 Newton meter, we may go through and just toss the printer up here real fast and make sure that we've got right torque values on the screws there. Timur, I don't believe there's an issue with like these NEMA 17s that we use. right? So I've used the same motors in 12 volt and 24 volt systems. There's no issue there. I don't think there's going to be an issue taking them up to 36 or 48 volts, as long as your stepper driver and your controller board can handle the current. Your motors should. Now, if you're getting down into the smaller motors, right, and I'll show you what I mean here in a second. So if you're getting down into like these motors or these PBYJ motors, the unipolar ones, these you can get in 5 or 12 volt, right? But most of our NEMA steppers that we're using for our 3D printers, I've never gotten one that said 12, this is 12 volt only or this is 24 volt only. So my point being, I don't think it's the stepper motor. I believe it's the stepper driver. Ah, that would be why. So that had gone to sleep on me. So let me uncrank that a bit. Turn this back on. And it kind of resets. So where it says it's at 1, but I'm going to go ahead and reset it. So now it's reset to 1. Okay. So we've got our 4 motors set up now. Now what I want to do, since I currently have this set to 1 Newton meter, and I know it's what's required of these, I'm going to go through and check all of these to make sure they're at 1 Newton meter. Yeah, we'll just say that, yes, all of these were at least 1 Newton meter. Hey, subsector. Did you ever use a torque screwdriver with your dad's stuff? As far as the RC cars and drones and stuff went? Okay, and all of those were, and there was none of them, these are just locked in, snugged in with magnets and tensioners. So we'll work on getting these done in a later step. So we're good there. And we'll go ahead and just let this time out. So we'll just set that aside and let it time out. So we've got our 4 motors mounted. Now we need to go back to page 31. And I'm not ignoring you, Modlight. I did see that it was the motors that would burn. Yes, a long time. Yeah, mostly wrenches. That's what I'm used to seeing is, the torque socket wrench that we're using foot-pounds. I've got one that'll do inch-pounds now for the plane, but I've never seen the torque screwdriver, but it makes sense that there would be one. You should be able to look up the specs for the Moon's motors. Just put in the model number, and it'll bring up the spec sheet, Timor, and let you know what they are. I do know I have like certain, you'll have a hot end that's 12 volt or 24 volt. There's nothing in the hot end that's 12 or 24 volt except for the heater element. So pop out a 12 volt, put in a 24 volt, and you now have a 24 volt hot end, right? Fans will be fans. You always check fans for values like that as well. Normally your smaller fans, like if you get a, I can't even think what size they're like 25 by 25 by 5 or whatever. Those are 5 volt. I normally don't see those at a higher voltage. So mod light. That's why on the torque chart, let me go back to that torque chart real fast. So M3 going through metal into a brass insert is a 1 Newton meter. M3 going through plastic into plastic is 0.4. So they actually have a different setting depending on whether you're going through plastic or through plastic into metal or through plastic or metal into an insert. So you got to know, each one's going to have a different value. And that's why I was specifically looking for one that had the right range from 0.2 to a 3 or higher. So that's why I was looking for the Vanpo, is what I wound up going to. Yeah. Yeah, so that's where I've got to keep coming back here. But I knew since I was doing the M3 metal to metal on these, that I knew I was good to use the same one for the linear rails. Now, if we were using the plastic parts here, it would be M3 through plastic into metal, which I'm not seeing that here, but it shows 0.04 is plastic to plastic, and that's probably what I would have used so that we didn't compress it down. Oh, you're talking about RC drones and going into carbon fiber plate? Yeah, that would, yeah. And I'm sure they probably would have figured that out if we were actually using a carbon fiber. But for now, let me jump back up here to page 31. and we'll start working through here. So we've got our motor mounts installed on all four, and we're going to do two different types, right? There's two different types, and one's a top drive and one's a bottom drive, and I'll show you what we mean in a little bit. Yeah, most drone builds won't have inserts. So we're going to need a couple of parts, and I've got my parts set out so they're kind of, how do we show this? So each side is slightly different. So there's two that go one way, two that go another. And then these other two parts here that you see on the right-hand side of this page, they're all the same from what I can tell. So just two on that side and two on this side. Okay. So we need to put some 625 bearings. And of course, I've got 3 different size bearings in this bag, so that'll make it fun. We'll just dump them out and find our... Okay, we're going to grab all of our small bearings and put them back in here because we don't need those. We'll get those out of the way. We're going to grab our 623 flange bearings and get those out of the way as well. And I'll just leave our bigger bearings. Okay. Yep. Okay, so we're going to start off by popping a bearing in through the top here. And it should just press fit in nicely. Should. Probably help if I actually started to put it in there straight. Yeah, that's a very, very tight fit in there. Let's get this started and then pull it down with a M5 screw. We're going to have to play, what's his name? Ivan Miranda. M5 screw and big washer and a nut. Now let me pull that into the part. And I'm looking for some thicker washers, which I had in here that I knew were in here. Because we've got a little bit of a gap there, so I'm going to need to put a thicker washer in there. And an M5 nut. I'm going to need one that's a little bit longer than this. Uh, 5x10 and 5x12 and 5x16. And let me grab an M5 nut. Oh, yeah. And I'm just going slowly, and it should press that bearing right down into the part. And I'm going slowly, so if I hear or feel like it's binding, like it may crack, I can just stop and not break the part, and we'll figure something else out. But this is a good way to get your bearings pressed into a tight part without having to, like print loose parts, because you want bearings to be a nice, good press fit. You don't want them loose. And there's a little bit of give to the polycarbonate, just not a lot, because this is PCABS. There's a tiny bit of give to it. You just want to make sure that you're using the right size bolt too, so that it sits on the center race. It doesn't actually go onto the bearings itself. Those two are nice and pressed flush. We'll sit those over there. These other parts come in from the bottom. We'll see if we have to do the same thing to these. And that's going to be a yes. That's going to be another tight fit. Now I wonder if that will go down in there. Yep. We'll wind up pulling this one. No, it's not going to work. I'm going to have to go that way. Yeah. So I wonder, this might just be a bit of elephant's foot on the part. So let me just chamfer the edge slightly to get off any elephant's foot. It's going in. Part way. Same thing. Bolt, washer, nut. Drop things, because why not? Well, I've watched Ivan Miranda do this a lot to push his bearings in. And that way you can get your bearings nice and flush and well seated in there. Okay, that one went in just fine without any additional assistance, so that was nice. We'll do more of these. Come on, Luke, you know the drill. We're going to deburr the edge just a tiny bit, so 1 or 2 passes with a deburring tool lightly. And that's just chamfering the edge. And that pressed right in. That one pressed right in. We're going to be able to chamfer that one with the tool that way. Bolt, washer, nut. And then just slowly screw it down. Should be going in easy. You'll feel it fully seat, and you can just back out the bolt. And one last one. Okay, so M5 by 16, M5 nut, merge M5 washer, they'll all go back in the motion kit box. Okay. So we got our 4 pieces, top and bottom, and we're going to be using the, yeah, so just looking at the way it's showing it, we've got this feature where the lip is up, where this feature, the lip is to the side of the printed part. We want this feature where the lip of the screw hole is up. So we're going to use this one, and of course, 2 of these. Why do those look like those are different parts? Hold, please. Just waiting to verify real fast. I think that's just going to be the idiosyncrasy between the V1 and the V2 parts. So the 1.1 and the 1.2 parts. Everyone still with me? Chat got quiet. How's everybody doing tonight? Time for some coffee break? Okay, so we're going to build the top driven gears first. So we're going to have 2 of our long boy motors. And we need to figure out if our idlers are 13 millimeters or 14 millimeters. So we'll take our idlers. These are our 9 millimeter idlers. Okay, definitely subsector. So these are 2GT 20-tooth idlers, 9mm width, so they're going to be 9mm belts, 5mm bores. And we got 4 of them. And we're going to use our calipers to determine, are they 13 or 14 millimeters tall. So open our calipers. And we have 13mm pulleys. So that's going to help us determine how many washers and stuff that we put in here. So these are 5mm shims, 5/8 ones, and 5/8 fives. So we've got 2 different types. We have 1mm and 0.5mm thick shims. So we need to be cognizant of that. Hey, Pezliz, how's it going? So the ones are on the right, the 0.5s are on my left. Okay, so we're going to start building a motor stack. And we're going to come down here real fast and just take a quick gander. So it looks like this piece goes towards the top. Really doesn't look like the right part. No, I got it. I got it. Okay, so this part goes down. This part goes like this. Pretty darn tight on that shaft. Ew. Yeah, I might need to sand the shafts. Yeah. Yep. That's what I just realized. We're going to have to sand these shafts. Give me a second. I think I've got some sandpaper over here. Because, yeah, those was tight. Them's was tight. Uh, what'd you laser engrave on them, TurtleCrawler? Oh, nice. And of course, I have no idea how much it's going to take to sand these down. Getting there. Oh yeah, it doesn't hurt to try, you know. Sounds good. Sounds good. So once again, flat spot, these parts, and these parts look right, correct? I mean, they're different than the parts shown. Okay, that's what I thought, because this is the 1.1 manual and these are 1.2. Yeah, that's what was starting to throw me off initially. I was like, these go on with the upper ears facing the plate. Dang it, I just put, there we go. Okay, so upper ears facing the metal plate. Then we have the 13 millimeter eyeler, so it's a 1 millimeter washer stack. So the 1 millimeter is over here on the right. So 1 millimeter washer. Then our GT2 20 tooth 9 millimeter pulley. And these surprisingly only have one set screw in them. We'll have to put a little bit of Loctite on them. I guess no, there are two on them. The set screws were in 3 of them, but not in the 4th one. That always helps. So we're going to build this one. Once again, I'm kind of building it upside down. So our thin flange goes against the skirt that we just, or the washer that we just put on there. We find the flat of my motor. Tighten that up against the flat. Same thing on the other one. Which goes against the round side. I'm not going to ugga-dugga it down just yet. I want to make sure that I can get everything on here first. You would install the plates on the frame, then do the stacks. Okay. The manual shows it this way, but are you saying mount the motor plates on there and then build, flip it upside down on top of the motors and then build your stacks? Because I can do that too. That might actually make a little bit more sense. So let me just get things off to the side here. Yeah, no, that's fine. That sounds good. Well, apparently, I'm not going to get that all the way off yet, but that's okay. It's just we need to make sure that when we build them in the right order. So I started building this one as a top driven, and top drivens get mounted so front, rear. Top drivens are in the back right and the front left. Then the other three won't really matter because we haven't started putting anything on them just yet. So let's get those lined up. Okay, so we're going to need M5. Says M5 by 16s. Are those still going to be 16s going through the metal plates? Do you know? You'd be surprised. You'd be surprised. Some old motors can sell for a pretty penny. Now, once again, they have these as M5 by 16s. I just don't know. Yeah, that would be kind of thick. I think, yeah, the corner can be that long because the corner is going into the pillar piece here, but the others are going to be M5 by 10s, probably. M5 by 8, M5 by 16. What were these? These were M5 by 20s. Oh, so M5 by 16s, if we got the right ones. Yeah, still not going to work. So M5 by 16s will go in the corner, and we'll use M5 by 10s. Yeah, to go into the side ones here. So M5 by 16 will go into the corner and it goes down into the pillar. Then we'll use M5 by 10s on the wings. There was some extra, there's like a whole extra set of screws. And if not, I can make up the difference. That's no big deal because, I've got the printed parts, but Hector sent me the nice CNC'd ones. So I'm never going to look a gift horse in the mouth, especially when it's providing me some nice parts. So Get those close. We'll put our M5 T-nuts in on each side. We'll grab the M5 by 10s. And I'm just getting these initially started, and then we'll torque them down all at once. So how have you been doing, TurtleCrawler? Have you guys been out on the Zero-G Discord a lot lately? Because I haven't been on checking the Zero-G Discord as much as I probably should. Still too many projects left unfinished yet. I guess I better put my M5 T-nuts in there first, huh? Know what you mean. And of course, it's coming into the holiday season, so going to be a lot of unfinished projects that sit around for the first of the year. Of course, I'm hoping I'm able to, we're going to do a 2-week shutdown, so I know I'm going to have to be doing some stuff over that time because I've got a test regimen to run on something. But other than that, I'm hoping I might be able to get some extra streams in and do another build as well. We'll see. We'll see how far we get on this in the next week or so. Your K3 still needs wiring? Oh, okay. See, you've been working on it, but you still don't have it all done. Now, what were your, did you use the 2004 Long Boys? Or did you go with which motors did you go for your X and Y? And are you using 24 or 48 volt for them? Hey, 491 Phantom, how's it going? Now, Phantom, I don't know. I think you went through before me through tech school down in Biloxi, but we had the Op-Tarts, which pretty much all they had to do is be able to type 60 words a minute, and they were basically done and out of tech school. And then we were like, I think we called ourselves the Four Non-Blondes or something like that because we were one of the other shorter ones as well. And then you had like the tech controllers, the 2E2s that were there for God knows how long because they were actually doing like soldering and all that good stuff. I know our biggest thing was just trying to get, be able to write, was it like format line 2 of the message traffic right? Get stuff out and to the right place. October to December of '89. Yeah, I went in and when the hell did I go in? '92. So not too much further past you. Have a level ASCII tape. Oh yeah. We were going to stay 24 volt, but didn't like how the 300 UHP fit. They ordered water rots and a 200 watt 24 volt, 48 volt UHPS along with better long boys. Okay, tore things back down when it was mostly built. Then I wanted to engrave the motor plates before installing the new motors, and I wanted to sit on the design a bit before engraving them. Well, yeah, because that makes sense because engraving only works really once. Okay, Turtle is back. So I've been reading various things, and it's if you go with the the 2084 motors, then I think you've got to use couplers, and if you're running them 48 volts, you've got to be running like 300 millimeters a second, or you get weird resonance issues. Yeah, they like a lot of power. Yeah, I've got some 5160 Pros from Big Tree Tech that I just got in, and I was debating like, do I run 48 volts right off the bat on the 2004s, or what do I do? Haven't quite decided yet. The old teletypes. Uh-huh. So I was dealing with the mainframes that had like the disc platters that you had to lift way up, and if you didn't get them straight in there, they wouldn't lock into place, and you'd have to, what was it, the FAMPI system, I think it was. Hey, thanks for the follow, Morph the Doomed. Welcome on in. Okay, so these are M5 screws, so we're going to bounce around real fast. So what, we'll have to build these in the right way. But I'm going to jump back to, what page are we on? 35. Okay, I'm going to jump back to page 7, which are our torque specs. So for an M5 screw, metal into metal, we're looking at 3 Newton meters of torque. So we're going to pop out our 2.5. And we need to put in our yep, that's the right one. Put in our 4. I'm going to set this down. I'm going to turn it on. I'm going to reset it. And our units are right, but we need to change the setting. And we're going to go up to 3. Okay. Then I just locked it in there. So we're at 3 Newton meters. So now as we start to crank these down, I'm going to start in the back corner. And once again, we're cranking, and it gives me both a verbal tone and it'll light from green to red as we get closer to hitting the number. This one should be visible to the camera by the time I get over there. Nope. Okay. So these ones are torqued down. We're just going to work our way around. They just punched or phased out the punch cards. Yeah, I never had to deal with the punch cards. But I thought it was awesome that my first duty assignment in Elmendorf Air Force Base up in Anchorage, we were dealing with the FAMPI systems and we were still printing everything out in like 6-part printer paper, or we had like 2, 3, and 6-part. So you had to constantly be switching things up to run print jobs. And then you had to separate and collate the number of copies and where they went to and everything. There's 2. Yeah, this is my first time using a torque screwdriver, and that's pretty neat. And I'll have to admit, this is the first time that I've had a printer, like I said, that actually tells you what torque values to use. So I figured, why not? We done all four? I think we've done all four. As I'm sitting here talking. Yep. Yeah, I guess we did do all four, huh? Okay. We'll set this back over here and just let it rest for a bit until we need it again. And where were we at? This is our front tag. So I've just got a piece of tape marking our front. And we're going to be building, go back to 35. We're building our top driven so front, rear, right? Top driven here and here. And then these are our bottom driven from the right, left, or the right front to the left rear. Okay. So we're going to flip these over. And we're going to do our two top driven versions. So that's this side over here. Make sure that goes down and lines up. So we've got our printed part. Here, let me bring you guys in a little bit closer maybe. All right, so not close enough or not low enough. So let's see about dropping you guys down. Ooh, that was loud. There we go. So we've got our printed part, and that's made to go right down between these linear rails. So we push that all the way down. We've got our 1mm shim because we are working with 13mm pulleys. Or excuse me, 13mm idlers. So we need our our pulley, and we're doing these upside down, so our thin part of our pulley is down facing. I need to loosen up the grub screws, and this is probably a different one, so I'm going to put some Loctite on these grub screws. Install the bolts on the plastic parts now. I can see that. Let me go ahead and get this on. We'll slide that down there, make sure it's lined up with the flat. Lock that against the flat. Lock this side against the rounded edge. And with 13 millimeter pulleys, we'll need a half-inch washer, or a half millimeter washer stack. So that'll be one from the left side here. And literally just one, not 80. One of our super duper thin ones. And then I'll take one of our idlers. And then we'll need a 2 millimeter washer stack underneath. That's two of our 1 millimeter washers. Or shims, I should say. One, two. And then we'll follow Turtle's advice and run our 2M5 screws in here. So we'll be able to get those started. Those lined up. We work for NASA. The hot mainframe computer was an IBM 360. Yep. I'd also install the bolts on those bearing blocks now. They're blocked by the lower block. You actually have one of the old platters after the, yeah, a lot of people were having them laser engraved as clocks or going away items. So it's the ones up here that you were talking about versus the ones down here. And then I do have the endstop blocks as well. So, oh, that would be fun. Hey, Nick, welcome on in. Yeah, 4 screws in the top mount. Yep. Because there's 2 that back here and then 2 that go in back here. So I'll be looking at those here in a second. I think it shows building the block and then talks about doing the top screws. And these would be M5 by 12s, button heads. Could use a 3 millimeter torque wrench. Yep. Yeah, I know there will be some end stops that go in as well. So that's why I'm not going to torque these ones here down, because I know they may not be final position. And why does that feel like it's not grabbing into anything? because it didn't. All right, give me half a second here. Okay, so these two are just snug for now. The two that go in the bottom, these are the ones that will attach to the end stops, right? Yeah, that's what I figured. So these two will hold on to end stops. The next ones will be M5 by 20s, and it wants you to come in and add the end stops. I see the screws right there, but they're not calling them out. End stop caps. So M5 by 14 if it doesn't have an end stop, M5 by 20 if it does. Front motors. So the front right motor, which this is our front, right? So this is our, sorry. So this is our front. So this is our front right motor. This is our front left motor. Which the front, here we go, front left, no end stop on the front edge, on the left edge, so this one gets the Y min stop left. Wow. So we need an M5 by 14 socket head cap screw. And there are already the M5 T-nuts are in here for when we put our linear rails in. So M5 by 14 socket head cap screw. We're using the front left motor and the front left. There is no end stop, so it's an M5 by 14. So this is kind of like why it's great that we have people like Turtle here that can tell us like, hey, you might want to be paying attention to this, or you might want to pay attention to that so you don't run into an issue down the road. So this is an M5 by 14. This is going to be the Y minimum L, and we've got, kind of hard to tell, but this is Y min, whoops. These ones kind of jacked out a little bit. Let me see if I can get that. So this says Y min with L. And then this one is Ymin R. So we're going to be using this Ymin L. And I will assume, I know that makes an ass out of me and you, or me and me, that the larger, so this is going to fit around the rail, and then this is going to jump up and go over the printed part, just like that, which is why we're going to need our thicker M5 by 20 screw now. M5 by 20. Okay. And once again, these are through plastic into metal. And our through plastic into metal for M5 screws. Well, that's awesome. So it doesn't really give me a through plastic into metal. And I am not going to put 3 on these. So these ones I'm just going to do by hand. And we're just going to just show them a little bit of love. And now the only other thing I need for this is the cap, which will be, let me go back to roughly page 37. You see the cap piece, right? Yep. The cap piece will go on there, and the end winds up being right at the top of the bearing. So that's good. And these will take what when we put them in there? M5 by 20 socket head cap screws. I guess it'd help if I put some T-nuts in there. It's going too far. Hey, almost done with one motor. Can you believe it? Hey Ozzy, how are you doing today? Yeah, I know the end stops only go in certain spots, so we got to be cognizant of that. Um, and once again, we're building the opposite motors the same way. So I'm going to take this and turn it 180 degrees. Set this down on the motors. So this motor is the front left. Let me think about that again. Yeah, front left. So this is the rear right. Yeah. So these two get built the same way, and then the other two get built the same way. So now that we've got one built, we'll be coming in here and using the same parts and doing the other build. And of course, we'll move those out of the way. And now we need to sand our rod. Corbett doing good. Uh-oh. So we will sand this a little bit. Right, and sand it smooth with the lighter one. So this is where using the couplers and shafts would be a little bit easier, because trying to sand motor rods that spin around kind of sucks. Okay, so we're going to start with this weird looking one. And once again, these parts are going to go right between the rails and the piece here. That sucked. Apparently that was not done all the way down. Ay, ay, ay. Here we go. That's there. And our stack with our 13 millimeter idlers is, that's a 1.5 washer stack. I don't remember doing a 1.5. I just did a 1. Man, now I need to take the other side apart. So 1.5 is going to be a 1 millimeter shim. And a 0.5 millimeter shim. We're going to need one of our pulleys. Once again, because we're doing a top-up stack, Hold on. Do this the right way. Top down stack. 1 millimeter washer. Take off that other half. See, I almost got myself caught. 1 millimeter washer. Then our pulley with the thin piece down. We're going to find our straight part of our shaft. Black set screw on black pulley, looking at a black part and a black table. It's always fun. Oi. Sorry about that. There we go. Okay, now next up is our 1/2 millimeter washer shim piece. Now we need one of our idler bearings. And then we'll need 2 millimeters of washer again. So we'll need 2 of our washers over here. Oof. Not good, Ozzy. Be careful. Take care of yourself. Get those 2 on there. And before we put the top piece in, we're going to go ahead and start screwing our pieces in here so that we've got access to everything. Let me see if I can set you guys in here now. You can kind of see a little bit more about what I'm trying to do when I'm getting these lined up. I'm just kind of pushing them in some and using the driver to line them up in the hole. Those 2 are in and lined up. These 2 are in and lined up. So these 2, once again, were M3x12 button heads. They're going from button heads in one spot and socket heads in another. And the only thing that drives me nuts about that is they're different driver sizes. So I'm just getting these engaged at first, and then I will tighten them up together. Yeah, you blew your knee up, wait for, yeah. So is it a meniscus tear then, Ozzy? Or was it a tendon tear? We're just going for feel on these. We got those 2 done. We need to do these 2, but before we do these 2, we need to figure out if we have to put a, because this is the other top driven. So this is the back right one, the rear right. And the rear right no end stop here towards the rear center would get a X max. So that's our, our X max, one of two. So this is going to fit right here. Go ahead and get the little end stop thing out of the way. So this one's going to go here, and then this one gets the no end stop because this is the right heading towards the front. No end stop here, M5x14 socket head, M5x20 over here going through the mount. So M5x14 socket head. Give me my socket driver. I'm trying to be careful. I just nicked that. So let me switch over to my ball head drivers so I don't damage my rails anymore. And an M5x20. It goes down through the Y max here. Not Y max, X max. There we go. Now we can put our final piece on. That's going to just sit right in there, and then we'll put our M5 T-nut and our last couple of screws in. Which I can't remember what these were, but we'll find out real fast here. And 5x20s as well. And I see to get these pushed down and lined up. And on 5x20. Hey, Aaron F. Geared, how are you doing? Hope you're doing well. We are building this upside down, so we're going to hope and pray at the end of this that we flip this back over and we double check everything. It's all in the right spot. Otherwise, you might see a grown man cry a little. It'll be a little depressing, but it'll be all good. But welcome on in. Welcome on in. Okay, so those are done. Now we're going to flip over and we're going to build the other two stacks, which are going to be the bottom driven. Yeah, that makes sense. So I'm going to pick this up, slide that over that way, and put you guys down here. And we're going to work in this corner now. Once again, we're going to take our like 80 grit or whatever. And I think it's like 120 just to clean it up a bit. No comments from the peanut gallery on my sanding. Going to give us still a pretty nice snug fit, which is what we want. Coffee break. Welcome on in, Aaron. We are, if you're not familiar, we're working on the Annex Engineering K3. This is quite an interesting build so far. So we're doing the two bottom-driven and stacks, and we've got 13 millimeter idlers. So starting at the top, we're going to have our standard top bearing piece. That's going to fit right in over here. Just like that. And remember, we had already put in the M5 T-nuts, so those should be lining up just fine. So we've got those in there. I'm going to get these out of the way. I guess while we're at it, let's go ahead and put in our other T-nuts and get this locked in place. And these were our M5 by 12 socket head, or button heads. 5 by 12 button heads. An Ultimaker clone? Is it? I honestly, I don't know. I've never worked on an Ultimaker. Sanding skills or lack thereof. Hey. My sanding skills work just well enough in the given situation. I am a good NCO. I do just enough work. Okay, and then these two are going to be dependent. We'll hold off on those for just a little bit. It's going to be dependent on whether or not we're doing end stops, and I would assume we're going to have a Y end stop here and an X end stop here. So this will be back left. Yeah, let's go ahead and figure it out. End stop. So this will be rear left. No end stop on either side. No end stop on either side on the rear lefts. These are M5 by 14 socket head cap screws. Okay. I know. I know, Monlight. Poking fun. It's all good. Luckily, my rods didn't need to be sanded too much. Just lightly sanded. So that works out well. And once again, I normally would not use a ball end driver for these to torque these down, but I am because they're really up tight to the extrusions here. And I did nick one of my extrusions with the knurling on my good ones. So don't want to mess those up anymore. So now we've got that figured out. We're going to roll back up here. And our two bottom driven, we're going to, with 13 millimeter idlers, we're going to need 1.5 millimeters of washers. So we're going to grab one of our 1 millimeters and one of our 0.5 millimeters shim washers here. So there's 1 millimeter. And the 0.5 millimeter. We'll need a GT22 idler. We'll need a 0.5 millimeter washer again. Then we're going to go on with our pulleys. Go ahead and get our we're going to Loctite on our threads. And these will go with the thick side down. We're building these upside down, by the way. So my flat's kind of facing the camera, so I'm going to slide this down. Make sure it stays down against the shims. And tighten that up against the flat. Come over to the side here. Torque that up. So now at the bottom, we're going to need another 1.5 millimeters of gap. So one of our ones. And one of our halves. 1.5, half, 1.5. And then we'll need our other bearing block. It's going to slide right in there. We'll add our 2 M5 T-nuts. Oofda. Well, that sucked. Okay, and once again, these lower ones were M5 by 20 socket. Alrighty. And bear with me 1 second. What I need over here. I just heard my motor piece behind me finish, and I'm reprinting the Z motor brackets because they, well, they just needed to be reprinted because the first ones I printed warped a bit. So the plan is reprint them one at a time versus doing all 3 at the same time. And then slowly drop the bed temp down. You know, like step it down, let it settle at 90, step down a little bit more, let it settle at 80, and just keep stepping it down. And then that way it will hopefully not warp any. So I am going to pull you guys out, and I am going to flip this 180 degrees to build the last motor. Well, maybe not 180. We'll do 90. Oh, 180. 180 it is. Whoops, sorry about that. Changed my mind and knocked you guys silly. Let me get you guys in here. Sorry about that. There you go. So last motor. Remove these end stops. And this is our front right motor. We're going to do a little bit of quick sanding here. Where my light's going to give me crap about my sanding again. Yep, that'll work. So same thing, our little two-eared piece with the two triangles. Use tight fit on there. And just like before, we're going to do 1.5 millimeters. So one of our ones and one of our halves. We're going to need our idler, a half. It's like a big jigsaw puzzle. Hey, Westry, how you doing, sis? How are you doing? Not just, well, if you get a Voron hardware, like a Voron fastener kit, you would probably have a good assortment, but I'm not sure if you would have the overall right assortment for a rook. Now, Fabrico has a rook kit, and they have, they have the fasteners and the linear rails and everything that you would need. I want to say it was like $200. The Rook 2020 frame kit is literally, I think it's like, was it? Yeah, it's 12 200 millimeter extrusions, and the corner brackets, you might be able to source those cheaper. All right, and so we've got our pulley, we've got our other, we've got our other 0.5 millimeter shim, and this is going with the flat piece down on our shaft. Now I'm like double checking myself. Okay. Yep, we're right. So we've got that on there. Now we're going to need another 1.5. So you could get a Voron fastener kit mod light, but I don't know if it will have all of the right screws and the right quantity. You might have to compare and contrast the bomb to make sure that it would have the right number of, the right type and the right number. I mean, you're definitely going to have more screws than what you would need, but it's whether or not you've got enough of the right sizes to build the rook out of. Okay. So we got these on there. We need to go ahead and mount this bottom piece that I almost forgot to do yet. So before we put the top cap on to make it easier. So these are M5x12 button head cap screws. We need to put in our T-nuts. So sis, we're doing good. We've been making some good progress. TurtleCrawler here was giving us some good pointers as far as kind of doing some things a little bit out of order, because we'll have access to these, no problem. But getting access to these once we put this top piece on gets problematic. So we're wanting to do these, which means we're having to jump ahead to figure out, do I have to put an end stop here or a different piece? Because it gives me different screws depending on where I'm going at. So my M5 shims, which go here. And I'm just going to try and tidy up some things real fast before I make an issue of things. There and there. Okay. So here I'm going to need M5 by 12 button head cap screws. And yes, you are seeing me put a little bit of Loctite on these, and then going through a plastic part. These are PCABS parts. I'm not that concerned about it. And I'm possibly going to reprint these in straight PC, possibly. I haven't decided yet, 100%. But I do want to make sure that everything is locking in good with these T-nuts, and that everything is staying nice and tight. Because this little machine can get up and boogie. Okay, now these two should be our last two end stops. That's what I was thinking. This is why I'm in. So I need to look at our end stop and make sure I put them in the right way. So this is front right motor. Front right motor has an X end stop. This is an X max end stop going along the front, and then a Y min right going towards the back here. Front to rear, front across the front. X. These are going to be M3 by 20 socket head cap screws that go in here. So I wonder, Turtle, if they're going to update the manual with these types of, like, put it over and build it in place versus building the stacks and then setting the stacks in. I mean, I get it, but that could be a real quick gotcha that makes you completely undo a bunch of stuff. Yes, so once again, this is PC ABS for this build. I specifically wanted PC because it was printing at a higher temp. It's going to be resilient at a higher temp. But I didn't have chamber temps to support straight PC yet. So by doing PC ABS here, I should be in a position where I can get this chamber up hot enough to be able to do straight PC. That it's a smaller chamber. So that's the other thing, is using a smaller chamber, you can normally get higher temps. So my Vorons, I'm getting chamber temps in the high 40s because they're 300 mil size, and the only active heater in them is the bed and the hot end, right? Where on Bubblegum Dragon that went to Free Heathen, it had PCABS parts as well, and it when we were putting the PCABS in it, which was once again the 280 on the hot end and 110 at the bed, it was getting up to 55 in the chamber. Well, and that's why I'm wondering if they maybe changed it when they're doing the revisions for the 1.2 version, because I'm assuming that some people are that they're going to change some things up because some parts have changed the way they look. I know that I just used that assume word again, so tell me if I'm calling myself out. Okay, and these are what am I thinking of? These ones are M5x20 socket heads. Yeah, that's what I figured was most people were building from CAD. And really the only build videos I've seen for a K3 are Golden Jaguars on YouTube's like a year ago. So I've seen K3 printing videos, and a lot of those are short, but there are a few like 25, 30-minute, watch this full print go. But for the most part, there's no build videos out there for these printers. Okay, so we've got our 4 motor stacks, and we've got them in place. Now we're going to do some verification. So I'm going to take this camera off. Let me shut this down before I start moving it again and give you guys all the heebie-jeebies and nausea again. Let me get that out of the way. We're going to set this back up on its feet like normal. And this is our tape flag. This is front, right? Let me put these up real fast. I think these are the M5x14s that went with the M3x40s there. These were M3 by something, 8s or 10s. M3 10s. Let me put these up. 3 8s. Those 8s. M3 10. 20s. All right, folks, give me 1 second. I'm losing my mind here. Here we go. M310 back here. Yeah, we're just going to dump those back in there. All right, so we're cleaned up. Now, front, rear, these two are bottom driven, which means our drive pulleys will be on the bottom and our idlers will be at the top. These two are top driven, which means our drive pulleys will be on the top and our idlers on the bottom. And those two are correct. So all 4 motors are in the right spot. Yay. Now what we need to do is verify that our end stops are in the right spot. So no end stops in the back or on the back left. Back right, we're going to have an X max. So there should be an end stop here. There is. No end stop on this side. That is correct. On the front right, we'd have an end stop at both corners. So that is correct. Front left, we'll have a Y end stop. That's correct. No end stop on the front. And that is correct. Yay! Whew! That was big. You're going to have to bounce y'all. Me and Delta are hungry, and make sure if you get the prints done. And yeah, I'll let you know the tracking number once I get those prints done. Like I said, I'm hoping to have them done and on their way to you this weekend, Mod Light. And I'm glad you liked the color combo. For those of you that weren't with us earlier, give me 1 second to get my iFixit kit back together so I don't lose things or knock this over and then have real problems. We looked at the colors for the Rook 2020 that we're putting off for Mod Light. And the colors he wanted was blue and orange. So we've got the dark blue and orange. So the dark blue is all PLA. And we're going to do orange ABS. And this is going to be for the bed and the rookery, so the hot end mount. So we're going to be doing the blue and the orange. So good colors. Good colors. Okay, so XY motors are done. Hoo-ah! Now we're going to move into the XY gantry. Once again, our X is a rail that moves in the X-axis. The Y is a rail that moves in the Y-axis. Okay? Yes, with a black 2020 frame. Yeah, and have a good one, Mod Light. Now it talks, the first thing we want to do is de-rack. Okay? So I am going to flip this back over so it'll be easier to de-rack the frame. Because what we're going to do, set this on all 4 motors, get these motor cables out of the way. Okay. So what it wants us to do is loosen all 4 of the screws on the rails. So this is our X. We're going to make sure that all these are backed off and loose on both sides of that rail. And I thought we left them all pretty loose to start with, so we're just loosening them up. And it says, unscrew the bolts a few turns. Next, move both axes against the end stops. So on the X-axis, our end stops are here. This might work out to actually have you guys in a little closer. So let me bring you guys up here. Hopefully without making you sick again. And folks, give me 1 second. I'm gonna go on mute real fast. I need to blow my nose real fast. So give me 1 second. Okay, thank you, folks. So we've loosened all the bolts on the two trucks. And now what it tells us to do is just bring it up against the X end stops on both sides. And you saw that when I brought that up, it was at a little bit of an angle. So when I brought it up, this side hit and then the other side came around. Now, once the axes are properly positioned, tighten the rail that was loosened, and then we'll check it for fluid motion. So now we're going to go through and we're going to tighten all of these screws down. And these are M3s going through plastic into metal, or 3 of them, and then the 1 is going into a brass insert. So we can look at our torque values and torque this down afterwards. Right now I'm just getting them hand tight and just kind of locking things in. Now we're going to check for fluid motion front to back. It feels like right back here it's starting to catch. But I think it just needs to be, run through the motions. Now we're going to do the same thing on this other rail here. Right, we're going to loosen all the screws. Okay. We're going to pull it all the way towards me, which is against the Y end stops over here. And I want to make sure that both trucks are fully up against it. So what I'm going to do is kind of just center my carriage and just apply a little bit of pressure to it. And we'll tighten down the screws on either side, making sure not to back it off the end stop. Yep, I got you, PoiTEE. So if you guys just heard what PoiTEE said, the screws that so these screws that go into the magnets that we put here, we can use those to adjust the skew of the rail that sits in the carriage. So see, this one I think really goes nicely, sliding back and forth the whole way. This one on this end is good, but back here it gets a little tight, like it's binding a bit, and we should be able to adjust with these screws. And the question is which way is it skewing or potentially skewing? Yeah, I'll keep playing with these and see what we got there. Keep working to make that smoother. You use 1, 2, 3 blocks on yours. Yeah, I'll take a look at it. I'll probably do that off screen just to make sure it's all nice and good and flush. Gotcha. That is a great suggestion, PoiTEE. We will do that. There's a printed part that you can use to mount to the cart to ensure how square it is or measure how square it is. Okay. Let me draw my other 1, 2, 3 block out. You can tell that I use both my 1, 2, 3 blocks because one is still fully encased. There's a tad light sheen of oil on it. And yes, that was said with a bit of sarcasm. You're talking about saying a 1, 2, 3 block. Oh, that's not going to work because it's. Did you have the 1, 2, 3 blocks sitting on something, PoiTEE? That would have been better done before adding a motors to the top. Oh, that sucked. What can I use? We'll use this. Well, maybe not. That's one there, one there. Still not going to be tall enough, is it? Nope. One flat and one up on top of it. Still doesn't, on my 1, 2, 3s, it doesn't make it that way. Probably if I bring it to this side, though, it might. Huh. Almost feel like I need one set on each side. I don't know. I'll play with it off stream and try and get it lined up and working and de-skewed. Oh yeah, no problem. No problem. That's why I figured it'd be easier without the motors. And now that I've got the motors on, it's going to be what it is. Like I said, these float real nicely. This one gets a little tight at the end. And of course, my normal thing would be loosen the bolts on one side and tram these two rails together using this rail to tram it. But yeah, we'll work that a little bit more. Um, the next step would be the tool head. To start assembling the tool head, begin by attaching the party plate from the desired tool head into or onto the linear rails. The party plate. Awesome. So let me turn that off. We'll come back to this screen. We'll move this out of the way. I'm going to pick this up and real fast just wipe this off because I keep hearing things grinding. There's probably a little bit of steel from me grinding motor pieces. So once again, the front is facing me. Okay. So this is the Y. This is the X. And it gets tight heading this way. Yeah, I'm going to have to resolve that before we get to the party plate. Otherwise, we're going to have issues down the road. So how do we solve that? Here's a thought that I'm going to have. I'm going to loosen one rail up. I won't be able to get to the very last screw, but that should be okay. And just loosening that up, this now floats a lot nicer. So just start to snug these down. Interesting, as I start to lock this down, that it does start tightening back up here at this end. Actually, before I do that, this is 2.5 metal through metal through metal, M3 socket head cap screw. So M3 metal through metal is a 1 Newton meter. Okay. We'll just do that one as best we can. It looks square to one another. Stepper motors are current sensitive, not voltage sensitive. Within reason, we'll do a magic smoke test to verify. Okay, cool. Yeah, I mean, that got them better. Still not 100% in love with it. Let me go through and do the same thing over here. It might just be that these are over torqued and complaining because of it. Which very, very well could be. And normally I would go from the inside out, but seeing as how I'm doing it, trying to make one rail match the other, and I can't do these two ends without taking it off, I'm going to work from one way to the other. That would ensure that any potential bow would be moved out towards the end. It could be something in the rail. You know, it could very well be just something in the rail that I'm not going to get out by doing this. So what he did was put a block against the frame on each side and make sure the frame first rail is square. Yeah. We'll flip this back over. We're up against the end stop. We're up against that there. So I mean, we're appearing to be pretty darn square. I'm a tad bit out of square here. Guess I probably need like a set of, do I have, got those clamps, but I don't have the other clamps, do I? No, I don't. Sorry, I'm hearing filament behind me going, and I'm like, So yeah, I'll play with that a little bit more to get it. A little bit more to my liking. Okay. Thanks for the alert, Timor. So it's talking about doing our plate. And the party plate I selected is for use with a Rapido hot end. I'm going to do the Rapido ultra high flow hot end. So hopefully I got all the right parts for that. But I'm going to do a Rapido ultra high flow and a mosquito hot end or a mosquito extruder. I did print the mirrored mosquito parts, so I've got those printed out. Those out of the way. That away. Sorry, I'm just afraid of knocking something over and then having to go and pick up a bunch of tools that are now splattered all over the place. Okay, so we've got our party plate and our tool head, and we need to take a quick gander and see which way this rocks. So front is where our tape is, so front's facing me. This is the rear. So looking at that, our party plate mounts in this orientation. Okay. Let me see if I can bring you guys in closer. We clean some of the stuff up on the very end of the workbench, and I'll move the printer closer to the camera. Okay. So printer is now closer to you guys. Our party plate. So this is the front, this is the rear. And looking at that, our party plate is going to mount like this. Okay. So you'll have a fan at the front and the rear. And it's going to mount basically like this. It'll be an ultra snug fit. It's sort of like that. And that really doesn't show up too well there, does it? So let me raise you guys up some. And point you down. Hopefully throw some white back there so that helps you see how that party plate goes. So this plate gets squished basically between the two linear rail carriages. And then once we apply the screws and lock these into place, then it becomes your full set party plate. Okay. So we're going to use, so before we go and mount that, we need to put in some heat set inserts in here. So we need 2 heat sets here. And then a couple underneath here. So let's go ahead and get those in here. In 3x4 heat sets. I was glad that I was looking at that because it's only 3 heat sets for my particular mount that I can tell. If I need to put another one in, then it'll be an interesting time. We use our M3 by 5 by 4 heat set inserts for these. And of course, I'm going to use my stealth press over here to get these put in. And the one insert I sent flying, so let me grab that one. Okay, so I think I've got the M3 inserts in that I need to have in. We'll kind of peek this through the cart like that. And we'll go ahead and unplug this and get it out of the way so I don't burn myself like I am prone and apt to do. Don't know if that print's going to get done or not. So we're going to start off with M3 by 8 socket head cap screws. We'll grab a few of those. And it does say to apply our whatchamacallit stuff, our Loctite. And we're using these 4 holes here. So 2 of them are low and then 2 of them are high. But this is for our hot end mount right here is these 5 hole here. So these 2 are well deep countersunk. So we'll be doing 2 here, 2 here. And I have a feeling, unless this is real darn close, that we're going to run out of filament on that print. I tried. I've got more filament on the way, but I tried. So I'm inserting these in a crossing pattern, and we'll tighten them up in a crossing pattern. These are M3 screws going through the printed part into the carriage. So we'll see what they want for torque value on this. Oops. Yeah, we're not going to get there. So let me stop that print. Okay, sorry about that. Where were we? So we got these four in. Make sure to align the tool head, aka party plate, with the gantry. Ensure it's square when tightening the M3x8 bolts. So we've got just the end, okay, so it shows us just tightening the carriage underneath. I'm sorry, just the top carriage, not the, so we tightened on the X, not the Y yet. Okay. So I'm going to check these four right here and set the torque for it and get those secured down. So these are M3 screws going through plastic into metal. It looks like it doesn't show plastic into metal. It shows plastic to plastic and metal into something else, but we'll go ahead and do the 1 Newton meter again. I'm not sure if that's what we had. It is. I'm angry at myself for putting this away earlier then. First time. We're going to go ahead and tighten these down once again in a crossing pattern. Okay, we're good there. Now it starts talking about adding our cooling fans in and building the 2 cooling fans and adding those. Then we do the tool head mount. Okay, so that's why we haven't done the Y rail yet, because it looks like our tool head mount itself wouldn't unless there's another part that comes in. But I think at this point, gang, we're going to go ahead and call it a night. It's 9 p.m. and we will come back and start working on our tool head fans. So I do want to thank everybody for being here. I know there's several other streams going on tonight on different platforms. Thank you all for being here tonight with me. I do need to kind of let my eyes rest a bit, and we will be back on Saturday for another stream. And Saturday's stream, we will not be working on the K3. We'll be working on the 2.4 build for Chewy. So we'll keep going on the 2.4 build. Yeah, so I will have to, I'll say, reset the Dragon Den here for the Chewy build. And we'll keep going on that. Hopefully we'll make good progress on that. We'll be working on mounting the gantry and running some belts. So that's always fun for a stream. But we made progress. This is kind of what I wanted to see done tonight, is to get these 4 motors mounted and start getting the gantry together. Like I said, we've only mounted to the X gantry so far, but you can possibly see the Y carriage is moving with it without a problem, because it is such a good press tight fit between these 2 gantries. So you can kind of get an idea of how it's going to move around a bit. But we're doing good. We're making progress. Whoops. Let me switch screens. There we go. So thank you all for being here. We're making some good progress. Thank you, PoiTEE and TurtleCrawler, for being here and for all the suggestions on like building the motors in a certain way, and to be making sure that we're accounting for the end stops and being able to mount these bottom, or the top portions first before we mount the bottoms. It just makes it easier. So you're making progress too because you're not on stream? Gotcha. That's awesome, Subsector. So yeah, we made good progress today. We're making pretty good progress. Looking at the manual, I guess, give me 1 second here. We'll take a look at the manual. Where are we at? Full display. There we go. Looking at the manual, we're going to build our cooling fans, get those mounted on each side. We will mount our chosen tool head. This shows a Mosquito. We're not using Mosquito. We're going to use a Rapido 2 ultra high flow. Hopefully we got the right printed fans. If not, we'll solve that. We've got this little printed part back here that gets mounted into this party plate and then into the carriage. That's why we haven't attached the Y bracket yet. We'll have a choice of using a beacon or a clicky probe. We're going to do clicky probe. So we'll be working on the tool head and the gantry system. And then we'll work on belting after that. So that'll be fun. That will be fun. So yeah. So thanks for being here, everybody. It's going to be fun. We're going to keep working our way through the toolhead build. We may have to go and look at some CAD here and there. So I'll make sure to have that ready to be looking at next stream. Let's see who's up and running tonight. I know normally we would jump over to like Big Jano or Creatix Brit, but I'm not sure who is on. I'm not seeing either one of those in my initial raid list. So let me jump over to Twitch proper and see who's active. I'm seeing Babe Ross, More, the Jang, Sid Hersey, Wana. Okay, there's several people that are doing the game awards, so I don't think we'll do that. The Jang is doing the charity stream for Starlight. Would I mind helping a very new person Lego builder? Not at all, Subsector. Not at all. Who do you got? Okay, so Western just mentioned more and more Subsector CTY 85. So more and more is doing the game awards. Let me check out. Art Fox is playing Fortnite. Take care, Chanel. He isn't affiliate yet, CTY 85. Okay, let me check them out real fast. Okay. Yeah, it looks like he's working on the UCS Razor Crest. Oh, from the Mandalorian. Okay. Yeah, let's go ahead and do that, Subsector. Good suggestion. I'm all about helping out new people that don't have a lot of viewership and haven't reached affiliate yet. So we'll go ahead and set that up. Let me get the raid started. So he just started. Oh, there you go. There you go, Subsector. So we're going to take Subsector's suggestion. We're going to go over to CTY 85. He's working on a Lego build of the UCS Razor Crest, which from what he's got pretty much the huge section of the main body built, which looks pretty awesome so far. I've got to stop playing with my eye because I have very dirty hands. Go wash my hands and put some eye drops in. But please go with me as we get this raid going. I'm going to go ahead and initiate or get the raid started. Please, everybody, let's jump over and show City 85 some love. And thank you all for being here. Saturday, Voron 2.4. Next week, we'll be back at the K3 build. Thank you all, and we'll see you on Saturday. Have a good night.